Hello everybody, my name is Gabriel Forbes and this is tackling stoichiometry problems in a nutshell. Okay, so generally what you'll be given is an equation and it will be like a specific hydrocarbon undergoes combustion with oxygen and yields carbon dioxide and water. So the first thing you want to do is you want to count the number of carbons, hydrogens, and oxygens on both sides and sort of fiddle with the numbers until you find the right answer. Okay, so on the left we have carbon, which is 5, hydrogen, which is 12, and oxygen, which is 2. On the right we have oxygen as being 3, hydrogen as 2, and carbon as 1. Not as carbon can't be C, carbon will be 1. Okay, so let's start off with balancing the carbons. So we're going to put a 5 here. In this way we get carbons are now going to be 1 times 5 equals 5. Oxygens will now be 10, 11. So that's going to now be 11. Alright, so now let's do hydrogens. Hydrogens, we have 12 on the left and 2 on the right. So let's multiply the hydrogens by 6. 6 over here. And we get 12 hydrogens. But now we have the 10 oxygens from the carbon dioxide and an additional 6 from the coefficient 6 in front of water. So that makes it 16. Okay, so last thing we want to do is we want to add an 8 on the left side, so that way we can get our oxygens to equal 16. So make that 16. So now everything's balanced, and what we got to do now is we'll have to solve the problem, which is typically you'll be given a certain amount of grams of a compound. So in this case we have 32 grams of C5H12 and 50 grams of oxygen, and the question is asking you to determine which one of these compounds is the limiting reactant. Okay, so this is where the stoichiometry comes into play. We're going to have to start off with our amount of moles of C5H12, which is 1, and we'll compare it to the amount of carbon dioxide produced. So we'll do convert the 32 grams of C5H12 to moles, so it'll be 32 grams of C5H12 times 1 mole over the molecular weight of C5H12, which would be carbon times 5, which is 12 times 5, plus hydrogen times 12, which is 1 times 12. So it's basically 12 times 6, which is 72. So 32 grams of C5H12 divided by 72 grams of C5H12. And I think that's pentane, if I'm correct. Okay, so looks like I forgot my calculator's right here. And we'll just plug it in, and we'll find that our answer is 32 divided by 72, and we get 0.44. So we have equals 0.44 moles, okay, of C5H12. All right, so if we have 0.44, how many molecules of carbon dioxide are going to be produced? So it will be, we'll have to use the mole ratio. So for every 1 molecule of pentane, C5H12, we get 5 molecules of carbon dioxide produced. So it's going to be 0.44 moles of C5H12 times 5 moles of CO2 per 1 mole of C5H12. So the C5H12s, they're going to cancel, and we're going to be left with 2.22 moles of CO2. Okay, and now we're going to have to do the same thing, but with oxygen. We have 50 grams of oxygen, so it's going to be 50 grams of O2 times 1 mole of O2 divided by 32 grams of O2, and we're going to be left with, so that's 50 divided by 32, and that equals 1.562 moles of O2, right? Okay, but we have to multiply this value by the mole ratio. And the mole ratio is 8 moles of oxygen produce 5 moles of carbon dioxide. So we're really multiplying this by 8 moles of oxygen of O2. Oh, sorry, multiplying this by 5 moles of CO2 per every 8 moles of oxygen. Oxygens cancel, and we're left with times 5 divided by 8. And we're left with 0.97 moles of CO2. Therefore, the values of our, the amount of moles produced for each of these compounds are 2.2 moles of carbon dioxide when the pentane is used, and 0.97 moles of carbon dioxide when the oxygen is used. So therefore, the limiting reactant is going to be the one that produces the least amount, and that would be the oxygen. So 50 grams of oxygen is going to be the limiting reactant. Okay, well that was how to solve stoichiometric problems in a nutshell. If you have any questions, feel free to comment or email me at gforbes@poets.whittier.edu.